So today I'll be presenting Solar tuning tips and tricks, share with you my experience on Solar that I've spent the last year working on performance tuning for. So first of all, start by introducing myself. My name is Mehdi Belmekki. I'm a technical consultant from the PS team, professional service team in Alfresco. I'm based in Paris. I am 6 years experience on the product on Alfresco. So first of all, I've started working on the community edition, and I've been awarded as the best community contributor for September 2008. After that, I've been working with the partners as consultant and architect, and I've got certified recognized developer. And then I joined the Alfresco team as consultant, technical consultant, and I've got certified administrator and engineer. My area of expertise are Alfresco repository side, Solar tuning and architecture, share extensibility and developments, troubleshooting, performance issues, authentication subsystems, and audit API in Alfresco. So the agenda for today will be, first of all, we'll set talk objectives and get an introduction of the presentation. Later on, I will discuss and talk, we'll work through the Alfresco Solar implementation, so the architecture, global overview of the architecture, indexing scenarios, different cluster architecture you can have. Later on, I will discuss the indexing process, how we can tune it, what are the best practices, and in case we have any problems with the indexing performance, how we can troubleshoot and fix these issues. I will do the same with search process, as Solar is mainly concerned by these two actions. And then we'll share with you some what we have on engineers' pipelines for the next release. Later on, at the end of this session, I will book some time to answer any question. So today's in the talk objectives, I will first, as I said, start with discussing the Solar implementation and architecture overview. After that, we'll talk about the options we have for clustering, Alfresco and Solar, and what to use and when. Later on, I will explain how indexing and search work inside Solar and how we can tune these services and what are the best practices for. And later, how to get fast search result, share with you some real-life examples. So I was saying, at the end, I will share with you some real-life samples. So real use cases from customers who had some slow performances on indexing and search that we tuned, and what was the state before tuning and after the tunings, what are the gains. And then I'll try to introduce some new feature in the engineering pipelines. So first of all, in the next slide, I will be discussing Alfresco Solar implementation, so global architecture overview, indexing scenario, two-node tiers architecture, which is the classic architecture cluster of two nodes, a non-dedicated tracking servers, which is a cluster with non-dedicated tracking server, no Alfresco setup on the same machine with Solar, and a dedicated tracking server, which is the opposite, that we will have a local Alfresco setup with Solar in order to help him manage the indexing and to scale in terms of performances. So this is the architecture of Solar implementation in Alfresco. So this is what we have right now. So there are two main actions. As I said, the search, which is the first one. So Alfresco is sending requests directly to Solar, and Solar streaming results in JSON files or XML files. And then we have Solar asking and pulling content and new created documents from Alfresco in order to get indexed in Solar side. It acts as well for the models, changes, and DCLs. We'll talk about the order of these calls. So for the indexing scenario, for example, when you create a document in the repository, Solar comes later. You have a cron that you can set up, and then Solar will come to ask for the new transactions, either it's creation, deletion, update, or any transaction, and get the list of IDs. And then for each ID, it will ask in this order for first the metadata, then it gets the content, and then it gets the ACL, and then this is the end of the process. So The architecture, clustering architecture we can have with SOLR right now is 2 nodes or maybe n node, but you will have 3 of the 3 applications on the same server on the same Tomcat. So SOLR, Alfresco repository, and share. Using this architecture actually has some limitation, is that if SOLR runs out of memory or you have any problem with SOLR, it will crash the whole VM, so even Alfresco or share will not be reachable anymore. Another limitation is you are using a shared hardware, so in terms of memory, you should know that SOLR needs a lot of memory, and if you sharing the same memory as Alfresco, you should at least put 8 gigabits or 10 gigabits RAM for the server based on the load you have in order to keep everything, the GVM healthy and everything well tuned. In terms of when SOLR asks for the content, there is a transformation load on Alfresco side. So when you put everything in the same box, the indexing process is impacted by the transformation load on the repository, even if it is 2 separate applications, but both are on the same Tomcat and share the same resources. So the transformation load, which is CPU intensive and sometimes RAM intensive, memory intensive as well, impacts on the indexing insertion and get your end user will have a bad user experience with. And in terms of scalability, it allows us only to have vertical scalability, so you can add more CPUs, you can add more RAM, but you cannot add only other Alfresco's instances, or you only have other share instances. You can add the whole box, but sometimes you will not gain performance like this. There is another option, is to use a non-dedicated tracking, which means that you have separate SOLRs or a firm of SOLR servers, which we call in index tier. This is suitable when you have a load on search, and then you can load balance your search queries on different services and on different SOLR servers. And when you have problems with performance, all you need is to put another server there. And even in terms of load for indexing, it is split on the other way, using the load balancer between both SOLRs. So the load, if you have 2, it will be split on 50-50 or more. And maybe you can even redirect the whole indexing load on only one server and leave the other one for end users. So end users are not impacted by indexing if you are doing some bulk injection or stuff like this. The end user will not feel the performance impact, because only one of both nodes will be concerned with the indexing stuff. So the advantage with this architecture is simple to upgrade, simple to administrate, and simple for maintenance. So if you have any problem with SOLR, you can switch off SOLR, but not the whole Alfresco, SOLR, and share, so the whole server. You can just switch off between 2 SOLRs, add another node, or switch off one of the nodes. And for the upgrade as well, you can upgrade first Alfresco and then upgrade SOLR, and you can split the effort between, instead of upgrading the whole at the same time, because everything is on the same box. And it allows as well to load balance your queries, and maybe in the future if we implement the sharding, so you need to have this architecture in order to use the sharding feature with SolrCloud and newest versions. When you use a dedicated tracking, this is the third architecture you can decide to go on, is to use one Alfresco local for SOLR and one Alfresco for share. So we have an end user, a repository tier, and you have a dedicated SOLR instances which are only used for indexing. So the whole transformation and indexing stuff and the whole load that is created on Alfresco when SOLR needs the content to get indexed is actually moved outside, which is on the same box of SOLR. And this will let the end user, this will make the indexing stuff and the indexing load, which is CPU intensive and RAM intensive, transparent to your end users, especially on the production side. So this is a recap of what I just said about this architecture. So as I said, indexing operation is offloaded from repository tier and client tier to an indexing tier, which is on the background. You cannot see it, for it is not seen by the end users. You have dedicated Alfresco for transformations, so you can tune your transformation. They have different transformation tunings, or sometimes you can tune the transformation timeout for the indexing, and let's say a timeout for 16 minutes maybe, or something like this. In general, we should keep it less. While for Alfresco, for end users, we want them to get share previews for a document of 10 megabits, which will take only 1 minute or stuff like this. We can tune differently the transformations for both servers based on the use case. For first one, it's for transformation for previews and share, and the other one, it's transformation configuration for SOLR and indexing. And this improves, in general, the performances globally. So now I'll be talking about the indexing process. So what are the best practices that you should implement and take care about? And once implemented, what you can tune to improve the performances of indexing. And if you still have problem, how you can troubleshoot this. And I will share with you some real-life samples, so before and after tuning with real customers we had. So the best practices, always care about having a local indexes, so don't use shared folder or stuff like this to put your indexes on. Use fast hardware, so in terms of, you can use RAID, SSD, whatever, but don't use shared folders or NFS share or stuff like this for your indexes. Reduce the caches if you are using a version pre-4.1.4, because the caches configuration, the default cache configuration there will most probably lead you to an out of memory when you have a big load on the server. Manage your RAM buffer size in SOLR config.xml file. This is by default set to 32, but in general 64 or 128 can improve performances, and it depends on the RAM available. You should not increase it too much. Otherwise, we'll run out of memory again. You need to tune the merge factor, actually. The merge factor 2 is ideal value for search, which will tune your search, but 25 is ideal for indexing. You should find the right value between in order to scale both and to improve both operations. During the indexing, be sure that you have a monitor tool plugged that will monitor your repository health during the indexing, because sometimes in the repository side, you have bottlenecks, so transformation is not working, or GC is taking a lot of time, or stuff like this. And this impacts on global indexing time. And people keep profiling and tuning in SOLR. Why the problem is outside? It's on Alfresco side that you should monitor and you should check. And in general, monitor JVM health as well in the SOLR side, because SOLR, as I said, is memory intensive, and you should really tweak your garbage collector for it. So once these steps followed, you can then move to tune your configuration. And maybe you should first think about, do you really need SOLR to track every 15 minutes new content? This, in general, in bulk indexing or migration from Lucene, when you have a big load of document that you want to index, this should be pushed to 30 seconds or stuff like this, so you leave some time for your indexed thread to process what they already get before getting more and put it on the queue. You should ask yourself if you really need SSL. If you are in intranet or stuff like this, you can just disable it to have less complexity on the platform. If you really need full text searchings, I've met some customers that run full text indexing, but they don't use full text indexing. Do you really need archive indexing as well? So you need later to increase your batch counts in order to get more results from your web scripts, from your indexing web scripts on the repository side, and tune the transformation on the repository side, which is in general the bottleneck on the repository side, and tune your JVM health and GC heap memory. So this is, now we'll be talking about troubleshooting. If you still face some problems with the indexing, you will need to test a lot of time and change the configuration and test again till you find the bottleneck, which can be on the repository side, database, I/O, JVM, and transformation. So database, sometimes you need to add more connections to the database. Sometimes on the I/O, if you are using virtual machines, there are some bottlenecks with the input-output with the disk read. You can use HD param to get to check the speed for read and for write actions on your disk. And you need to check the GVM. As I said, I always focus on the GVM and the transformation. On SOLR side, you can tweak the number of threads for the indexing. You can tweak the caches, the GVM hep, and GC configuration, and then you can think on adding more hardware. In general, the hardware is not the issue. It's just configuration stuff. And then you can tune, fix, and retest again till you get the performance you need. This is an example of a customer that is using 24-core machine, 64 gigabit RAM, which is physical hardware, and they were suffering from slow indexing for full text indexing, kind of 500,000 document, 500,000 document, 50 gigabits of data, all indexed in full text, and takes 3.5 hours with long GC poses in SOLR side and high CPU memory in Alfresco side. So while profiling, this is, and the first picture is for Alfresco side during the indexing. As you can see, all the thread was kind of red because they all were waiting for transformation, and there was problem with transformation server, and there was no timeout set by default. So all the threads in SOLR side, which is on the top, were doing nothing, just waiting for Alfresco to send back the content. Later, after fixing this issue, so things becomes like this, and as you can see that we have more CPU load. We have some activity on Alfresco side, and the threads are working now, and the content is streamed to SOLR, and now we have SOLR activity as well on the bottom, and SOLR is working again, and the indexing is working again. And the result after the tuning was kind of, we have now low GC poses, we have optimal CPU and RAM usage for both, so for Alfresco and for SOLR side, and we have transformation process which is tuned for indexing, not for end users stuff. And now the 500.5 million documents is indexed in 1 hour instead of 3.5. And when we try metadata only, it's 15 minutes. So this is more than acceptable for me. Talking about search in the next slide. So again, the same pattern, best practices, how to improve troubleshootings and real life sample. So the best practices, again, use local indexes, tune the merge factor, but again, be aware that merge factor should be here decreased in order to get faster results, in the opposite of indexing when you should increase it to get faster result. You need to decrease the caches, especially if you are running a version before 4.1.4, as I said before. Increase your query caches and profile for commit issues, which I mean by it's IO logs. And this stuff you can see it with profiling, because sometimes you are running indexing and search at the same time, and the access to indexes is locked, and the concurrent access to indexes just get worse performance with this. So you need to sort this out. You need at least to point it, and then I will explain there are some options to how to sort this out. So how to improve search? You should avoid path search. We'll see in later slides the bench or performance tests with and without path search, because it is known as a slow query. You should avoid sort, but you can do the sort in client side. If you are using GS or whatever in your client side, you can just use your client framework to sort. Don't bother SOLR with it. Get a faster hardware. Meanwhile, faster hardware, focus more on the CPU rather than the RAM. Separate search and indexing. If you can, get 2 SOLR box, one dedicated for indexing and the other one dedicated for the search. It will improve your global performance, let's say 10 times faster for both actions. Optimize ACL, so reuse your ACL, reuse your permissions. Use inheritance of permissions and use groups. Don't set up for each folder or each folder level on your classification folders specific permission for users or for groups. Try to optimize and to use and reuse your ACLs. And then, if just focus, this is an important point, is that you need to upgrade to latest Alfresco version on hotfix. We are guys in support, engineers, and consulting all focused on tuning SOLR. There is a lot of bug fixing that goes quickly in less than one month. You have a lot of things fixed, improved in SOLR. So if you can just put in your roadmap to upgrade to minor versions, maybe you will get important performance improvement between your current version and the target version. So search troubleshooting, first you will need to choose a load testing tool and design your scenario, maybe solar meter, custom G meter scenario, or maybe you can use the default Alfresco benchmark scenario. You need later to attach it, you need to attach your favorite profiling agent. Internally, we use YorkIt in general. This is our favorite toolkit. And use YorkIt to monitor, record performance snapshot, analyze it, and then tune and test again the search. So this is a real-life example from another customer which runs simultaneously indexing and search on the same SOLR box. So this customer was using virtual machine with 6 vCPUs and 8 gigabits RAM for 4 million documents. The full text indexing takes 5 hours, which is quite good, while the full text search takes an average time response 43 seconds and maximum peak of 10 seconds. But again, this is a specific scenario where the indexing and insertion are running in parallel. So if we switch off the indexing, we can divide by 2, we can have half time response for full text and for semi-search, which is while the indexing is running, an average 1-2 seconds and maximum 5-9 seconds. So what we've done so far, so we have first the initial state. After some SOLR changes, which impact on the caches and RAM buffer and all the stuff, after the time response, after some GC changes, now you can see we start getting better result in average for FTS, and we're moving from 4.5 seconds, 5 seconds to 4 seconds. And average sim is the same, so this is the gain we get with some GC changes. Once we remove the path, again, we have better performances for semis. Well, semis is metadata query only, while the blue bar is for full text search. After increasing the RAM buffer, now the full text search moved from 2.5 seconds to 1 second in average, while the semis query stays the same. After upgrading, we've got again now both under 1 second time response, and this is again scenario where indexing and search were running in parallel. So this is the worst performance this customer can get. If we switch off the indexing, we'll split time by 2. So after further advanced GC tuning, no changes, but with less memory at the end, moving memory from 24 gigabits RAM available for the GVM, the heap memory, to 16 or 12, make you some better performances and performances gain. Why? Because the GC poses are smallest, because the GVM, in order to garbage collect a big memory, takes more time than small heap memory. And then the final state now, after full text search is in average 0.8 seconds and maximum of 4 seconds, and semis is an average, metadata queries in average of 0.6 seconds and a maximum of 2.5 seconds. We have more free memory, so as I said, we decreased from 24 to 16, and even the 16 is not used at all, we use only 8. And we have now low GC poses, low resource consumption, and decrease the index locks and during the commits in iOS. So here I'm sharing a summary of important tunings for both. So in general, don't use a lot of GVM options. So when I visit customers, I found that when they face problems with SOLR performances, first let's start by tuning the GVM. And tuning the GVM doesn't mean put a lot of options and put a lot of optimizations, because most of the time this will impact badly on the GVM performance. You will get worse performance rather than better, because not all the options are compatible, and some of them are just run into conflicts, and this is not good for the GVM health. Don't use large heap memory. If SOLR use 18 gigabits, don't give it 32 until you are sure that there is no memory leak, that you've done all the tuning you need, and that you really need more memory, because otherwise there might be a memory leak or stuff like this, and just hide it by giving more memory. You do not fix the issue. Set the timeout for transformations, which are by default not set. and use only one subsystem. So either or direct for the transformation or JOT converter. Never use both because otherwise it turns into conflicts. Be sure you are allowing enough database connections. I've already seen a customer that use 14 connection in production environment. This just cannot work. You have at least to keep the default, which is 40 connection, or maybe tune it to 250 or more, and then be prepared to monitor, profile, and test. And I can warranty that you will get better performances for this. Now we'll be talking about what we have on the next release and what might be the plan for the next release. So the next available architecture, SolrCloud, replication, clustering, architectures, and we'll talk about sharding. All these are featured on SOLR 4, which is our target and priority #1 to get it on the next release, since we are now using our SOLR version 1.4, and we want to get all the future and bug fixes from 1.4 to Alfresco 4. So later on, the single server architecture, this is what you have with all SOLR, so even 4.1. The second one for replication, right now the replication is not working with the distribution we have. All you can do is use rsync to synchronize the indexes between both servers, between both replicated, between both slaves, or deploy snapshots. But you cannot rely on SOLR out-of-the-box replication mechanism. Later, you can use distributed sharding, so you can split your indexes between shards with SolrCloud, and you can combine between distributed and replications so sharding with replication on shards. So SolrCloud will introduce automatically distributed update among the clusters, so you shouldn't take care about routing the information, so the cluster will take care about. It will use transaction logs, so you will not lose your documents which are not committed. There is a transaction log which will take care and ensure that even uncommitted documents are never lost and are retrieved after you restart. You have SOLR will automatically distribute the search among a cluster or cluster of nodes or shards. Even a sharded environment, as I said, and it supports near real-time searching, so you can find the document even before it is committed to the indexes. In the next release, you'll get even the replication. So currently, as I said, the only workaround for replication, if you want to get two SOLRs, one for search and one for indexing, dedicated, one dedicated for search and one dedicated for indexing, and you want to replicate your indexes from the indexing server to the search server, all you can do is the workaround of using snapshot or using rsync. But most probably on the next release, you will get this feature working. So all you need is to configure on the master, point it to the slave, and SOLR will take care of the replication automatically. SolrCloud will manage automatically the replication inside SOLR cluster, and maybe, as I said, the replication will be embedded in our next Alfresco's release before SolrCloud become a part of the product. And SOLR replication will fix the issue of commit, while, as I said, when you have concurrent access to indexes between search and indexing operations. So this is the current cluster. So when you set up a cluster, you have to set up a load balancer and route yourself your queries between masters and master SOLRs. This is a custom routine and even a complex for provisioning. So you have a duplicated effort. All the masters should go to Alfresco and ask for indexing, and it just duplicates the effort. Like if you are running this only one box, you are not taking the benefit of running a cluster here. So after SolrCloud, you have a new firm design that you have nodes, and you have a zookeeper configuration which will manage these nodes. So you don't need to take care about where is the information coming from, where is the query going to, because the cluster is smart enough to route your indexing, provisioning, and route your queries and results back. And it provides the centralized configuration zookeeper, so you can just manage and administrate all your nodes from there. We'll just give an overview of Sharding, what is Sharding future with SolrCloud. So when an index becomes too large to fit into a single system, I'm talking about more than 50 million documents that you cannot index, or maybe you can, but in terms of performance, it should have an impact on performance if you index it on the same server. And when a single query takes too long to execute, because otherwise, if the single queries are all fast enough, you need just to replicate your server. You don't need to split your indexes or to use sharded environment, because with sharding, you will have one logical instance Solr running multiple instances, physical servers, Solr servers, but with splitted indexes for the same collection. So in this example, we have two shards. The first one holds 488 documents indexed, and the second one holds 512 documents. This is not two indexes, this is the same indexes, but split between two servers. So if you execute a search, the result will be 1,000. So both combined at the same time. Using sharding, you can decrease your need of memory, RAM per server, and you can drastically decrease the need of disks for indexes because you split the file system. So this is all for today's session. I'll let you share if you have any question or you have any problems currently I want to discuss with performance.
Do you have some recommendations for the caches, which sizes to use? Because we stopped using SOLR for big systems because of the out-of-memory problems. Thanks. For example, we stopped for 10 gigabytes RAM for the SOLR instance for millions of documents. So do you have a recommendation for the cache numbers?
Which version are you using currently?
4.2c.
4.2c. So caches are already tuned there because up to version 4.1.4, the caches was kind of initial caches or set to high values, so 512, 1 megabits or stuff like this. And then it quickly fill the memory. What we do is to decrease it to 64. So I think in the version 4.2c, you already have this decrease to 64, and you can even decrease it more if you need to 32 or stuff like this.
You mean 64 gig?
No, we are talking about caches or?
Yeah, sure.
Caches, yeah. No, 64 kilo octet.
Okay.
64
so because we get always out of memory after some hours.
So I don't think the problem might come from caches in this case. Because how many documents you have on your repository?
We started with 1 million documents.
1 million?
Yeah.
So it's not that much that you need really 12 gigabits or more RAM. For 1 million, you need maybe 6 gigabits RAM. It should work. So the problem might not be the cache, but it's something related to configuration. I didn't work with the community edition too much, to be honest, but I'm pretty sure that in terms of configuration, in terms of your hardware, 6 gigabits for 1 million is okay, is enough, is really enough. There is something with the configuration or something like this that might be tweaked there.
You just use the standard configuration?
Yes, the standard configuration is kind of, it is not suitable for all customers. It is there, it is maybe the optimal for a vanilla setup, but it should be tweaked based on the use cases. So if you have a lot of concurrent users, you should add more caches for the queries caches.
Yeah.
If you are using the Solr server for indexing, you should decrease the caches and add more cores and more threads for the indexes, decrease the cron to get more information from Alfresco side to index and have less waiting time in the SOLR sides. And all of this depends on your hardware. So, and in terms, when I say hardware, I'm talking about CPUs more than RAM, and it depends on how you use the system. That's why I was always focused on the presentation that if you can get two separate SOLRs, one for indexing, one for search, just do it when the replication is working, because it will help you to tweak each SOLR with the right configuration, because it's, the indexing tunings are, in general, the opposite of what you should apply for search. So you need to have separate box to tune both at the same time. Otherwise, still in the middle. So indexing and search are a bit tuned, but you cannot push things to the highest point. Any other question? It's okay. So if you need any help later, just feel free to send your email to consulting@alfresco.com or send it directly to me in mehdi@alfresco.com. Thanks for your attention, and I'll let you enjoy if you are going to your AC Milan, FC Barcelona football match. Thank you.